Hello and welcome to PCMINR.com, and you're watching this video on the factorization of algebraic expressions by Sonal Gupta. Let's see how we can factorize algebraic expressions. It's no different than the numbers. Like if you have to, you know that 1, 2, 3, 4 and 6, they are all the factors of 12. Sorry, this is 6. They are all the factors of 12. So you can write them this way. 3 times 4 will give you 12. 2 times 6 will give you 12. Right? Or you write in the other way, 4 times 3 or 6 times 2. The same way we can factorize the algebraic expressions. You have to look in for the common terms. There would be a term which will be common in both. Like I have written the expression here, 4x squared plus 8. You have to look in for what number can be common. Now this is 4 and this is 8. 8 comes in the table of 4. So it is a factor of 4. So what I will do is, if this is, it's a multiple of 4, or 8 has a factor as 4. So I can take 4 as a factor common outside, and then I have x squared plus 2. And you have done the correct factorization or not, that you can check by multiplying this back, and you get the same expression. Obviously, if you multiply this back, 4 into x squared would give you, just verifying the result for you, 4 into x squared will give you 4x squared plus 4 into 2 would give you 8. So yes, you got the right factors because you're getting the same expression backwards. Now I have another number as another example here. 4y cube plus 2y square. Now this time it's not just the number 2 which is common, because of course the moment you look at it you get to know 4 and 2. If you're good at tables, you can immediately make out that 4 is a multiple of 2 or 2 is a factor of 4. So obviously in this example 2 would go out. But there is one more thing. Y cube is what? It is equal to y square into y, right? So that means this also has y square common. So what I'm left with inside the bracket is just 2y plus 1. Because I saw that 2 is common in both the terms and y square is also common in both the terms. When I took out 2y square outside, here I have to multiply it with 2. You can see what I did. Multiply them back, you should get the same answer. 2y square I've taken out common, because if you multiply it with 2y, you would get 4y cube. Plus, if you will multiply 2y square with 1, you will get 2y square. So this is how you take out the factors common. I'll practice some more questions with you. So I have a question from here which says, it's given somewhat like this: 18k square minus 21k. So if I have to write this expression in the factor form, so in the factor form, what will I do? I see 18 and 21. They both fall in the table of 3. So first is, because 3 6s are 18 and 3 7s are 21. So I'll take 3 common outside. Here is 1k, here is k squared. So I can take 1k common outside. I am left with 6k here minus 7. Because this gives me what? 3k into 6k gives me 18k squared. And 3k minus 7 gives me 21k. So the moment you look at it, we come to know one numerical factor is common, which is 3, and k square and k. So k can be taken outside, right? They need to have these common expressions. Now I'm taking another question from your next question exercise. It's 14a plus 16a square. So I'm sure you know the answer. First thing, you look at it, 14 and 16, they're both even numbers. Definitely they fall in the table of 2. So I'll take 2 common outside. A and a square, definitely a is common. So multiply this with what? 2a times 7 would give me 14a, plus 2a times 8a would give me 16a square. So that is your final answer. So Tristan, if you have to understand the factorizing, you have to understand that tables are very important, because the moment I look at it, I know they both fall in the table of 2. So I could take out 2 common. A and a square is very obvious. A is common, right? So now if I give you where some numbers are not common, like I have 4h minus 7h square. The numerical coefficients are not common this time, because 4 and 7, they don't fall they're not the common factors of anything. So, but h and h square, only h would go out as common. So your answer would be 4 minus 7h, because it's h square. You multiply, you get back 4h minus 7h square. I hope you've understood how to factorize the expressions. So I picked up one more example where you can also consider it as to be using the HCF. So like, and if the negative sign is there, not a problem. Like I have here minus 9k and the other number is minus 15kx. I have to factorize these two numbers. Now negative sign is common here. I'll take that out. What is the highest common factor for 9 and 15? Highest common factor means for which the table for which both of them will fall in the same table. So 3 3s are 9 and 3 5s are 15. So 3 is another highest common factor for 9 and 15. And then k. K is common for both, so I'll take k outside. What am I left with here now? I know you know the answer. It's just 3 left inside for this, because when I multiply back, I should get minus 9k and plus 5x. Right? Because why I've written plus? Because I've already taken the negative sign outside. So when I multiply them back, what am I going to get? Minus 3k into 3 would give me minus 9k, and minus 3k plus 5x would give me minus 15kx. So this is how you can factorize. This is the answer you got as the factors. Let me do one more question for you. I have minus 11a square b and plus 9ab. So what will I do? I'll just 9 and 11, nothing is common, no HCF, it's only 1. But a square and a, so a is common outside, b and b is common outside, but negative sign is not common this time, so I'll write it as minus 11a plus 9. But negative number should not be written first, so I would rather write it as ab times 9 minus 11a. Right? That is the answer. I hope you've understood how to factorize the given algebraic expressions. Thank you for watching. Please follow us on Instagram and Facebook at PCMINR.com.